So we are talking about how variables are passed in JavaScript. Now, I've seen a lot of videos on YouTube about this concept. I think it's super important to understand this. Yes, at a surface level, it's important to understand for interviews. It's important to understand to inform the choices that we make in JavaScript. But I haven't seen anybody explain how these processes work under the hood, so that's going to be what I'm going to be going over today. So there are two main types of variables in JavaScript. We have our primitives, which are going to be numbers, booleans, strings, undefined, and null, and symbols, sort of. We're not really going to talk about that one. It's a little bit different. And then we have our reference objects, our compound values, which are going to be objects, arrays, functions, and more. So how are primitives passed? So primitives are going to be passed by value. What does that mean? So in JavaScript, we have something called the call stack. And what the call stack is a data structure that follows a last in, first out method, like a stack of pancakes. When you put a new one in, and then you have to remove one, the first one that was put in, the one that's on top, is going to be the first one that has to come back out. Whenever we are executing a function in JavaScript, we push a new stack frame onto the call stack. And whenever we are creating variables in the global execution context, for example, if I were to say, let my num equal 1, that's me writing code that is creating code in the global execution context. So whenever I'm creating my call stack or visualizing it, we have to make sure that we are accounting for the fact that there is a global stack frame there. And whenever I'm creating variables in the global execution context, they will live inside of that execution context, that stack frame there for global. What's interesting when we're working with primitives is if I were to say let your num equals my num, this is going to be a copy. It's going to be a copy of this value 1. So if I were to say now my num, sloppy, my num equals 10, and I were to console log your num. Now, when I created this variable, your num, I set it equal to what my num was at that time, which was a copy of 1. So I will see in my terminal, if I were to actually visualize this, the first thing I'll see printed to the console is 1, even though we have reassigned the value of my num after the fact, right? So that is passed by value. We're creating copies anytime we are working with primitive values. Now, pass by reference, right? Compound values are going to work a little bit differently. We have another place where we are creating memory in JavaScript. It's going to be called the heap. Whenever we create compound objects in JavaScript, such as an object, right? If I were to say const my obj equals just an empty object, what's basically happening under the hood is JavaScript is going into the heap and it's creating a new sort of tag. So let's say it was A12B or something like that. It's sort of like a home address. It's going to be a number that is referenced anytime we reference this variable, my obj. And attached to that tag is going to be my object. So if I were to now say const your obj equals my obj, basically what we're doing here is we're creating a pointer. Yes, my obj is passed by reference. It is a pointer to this place in the memory heap, but now we have a second pointer that is pointing to that same place in the memory heap. So both of these variables, anytime we reference them, are pointing to the exact same place in memory. So now if I were to say something like my obj.dog equals the string spike, and I were to console log your obj.dog, what would you expect to happen? Well, since we had added a property onto my obj, which is a pointer to this place in memory, right? That was a property that was created onto this object, dog, spike, and now remember that your obj also points to the exact same place in the memory heap. So when we say your obj.dog, it's going to point to the exact same object, have the exact same lookup, and we will in fact see logged to the console the same value, spike. So that is pass by reference. Now, things get a little bit more interesting once we start working with functions. So imagine that we are currently executing code, right? So we are inside of the global execution context, and let's say I have a function. Let's say that function is going to add nums, and it's going to take in two numbers, num1 and num2. And all it is going to do is it is going to add those two nums together and return them. So return num1 plus num2. So imagine that I'm going to create two numbers inside of the global execution context. I'm going to say let my num equals 4 and let your num equals 5, bearing in mind these were declared in the global context, so they really exist inside of this stack frame here. Now I want to call add nums and pass in my num and your num. Okay, so we're calling this function, which means we need to push a new stack frame onto the call stack for add nums. And now, inside of this execution context of this function that we are now running, because we are working with primitive values here, we're working with numbers, we are going to basically create copies, which will be these parameters here. These parameters are going to take in the values that we passed to them via these arguments and create copies of them, so that whenever we are doing some work inside of this function level execution context, what num1 and num2 are basically going to be entirely new variables, which will now live. They're basically stored in memory inside of this stack frame here, add nums. So again, pass by value, we're creating copies. Now, what happens when we do the same thing? We run a function, but we are working with reference variables. So let's say I have const my obj equals an empty object. We know that whenever we declare a compound object like this, it gets stored in the heap. Let's say this is going to be A123 is going to store a reference to this object I just created. And now I'm going to do, let's say I have a function which will add property to an object that we pass it. So it's going to take in an object, and what does this function do? It will just simply add onto that object a property called dog and set its corresponding value to spike. When we eventually get to the point where we will call add property, passing in my obj, we are not going to use a copy of my obj here. This parameter, which takes in this argument my obj, this parameter is actually going to create a new pointer to that same place in memory that my obj pointed to. So again, we are creating a new reference, we're creating a new pointer, so that even when, let's say, inside of this function, when we call this function, it adds a property onto that object. So this now will have a property dog spike. If I were to sometime later, let's say console log out the value of that original my obj, even though we have mutated the different object, right, this second pointer, we will see printed to the terminal when we console log out my obj dot dog, we will see the value spike printed to the console. So that is pass by reference. We're creating new pointers to the same place in heap memory. All right, everyone, that's going to be it for today. If you have found this video helpful, please share it with a friend. Feel free to subscribe. Let me know what you think. Add a comment below. I will hit you back as soon as I can. And thank you so much for watching. Have a great day.